Okay, good afternoon everybody, or good evening. My name's Chris Tuck. I'm Associate Pro-Vice Chancellor for Research and Knowledge Exchange in the Faculty of Engineering here at the University of Nottingham, and it's our great pleasure to welcome the Royal Academy of Engineering here and to have this public lecture that we're going to have later on. So this series of lectures was developed by Professor Phil Bennett, who unfortunately died last year, but it's a really important way for the Royal Academy to come out to the rest of the UK and to understand what we're doing. And we're going to have a discussion and lecture later on delivering net zero, something that's really important to us as a faculty and as a university. Lots to do, and obviously in engineering we focus on the technological changes, but we're very interested in how those play out for society, the environment, and obviously the economy as well. And Dame Julia is going to give us a great a lecture on that in a moment. So I just wanted to hand over to Trevor, who's going to talk to us a bit more about Julia. But just before I do that, a couple of housekeeping elements. There's no planned fire alarms that we have today. So if there's a fire alarm, please follow a member of our academic staff to the nearest muster point, which is outside the front of the building. And please ensure that your mobile phones are switched off. If you want to ask a question during the Q&A at the end of the lecture, please raise your hand. We have a microphone that will be milling about and that will be passed over to you. And we are recording the event today and we'll make that available on the Royal Academy's website as well. So, Trevor, over to you.
Thank you, Chris. So, very briefly, my name's Trevor Benson. I'm Emeritus Professor here at the University of Nottingham and been a Fellow of the Royal Academy of Engineering since 2005. Very briefly, the Royal Academy is the UK's National Academy for Engineering. It was founded in June 1976. And the mission of the Academy is to harness the power of engineering and to build a sustainable society and an inclusive economy that works for everyone. So the implementation plan includes growing talent, driving innovation and influencing policy. And this includes helping engineers and policymakers to create systems and solutions to address the climate crisis, which is the topic of today's talk. And hopefully we can support more sustainable use and management of our natural resources. So among our guests here today is Dr. Steve Denton, who's the Academy's newly elected Vice President for Committee Coordination. Yeah. So, primarily, I'd like to thank the University of Nottingham for their generosity in hosting the evening's event. My sincere thanks to Paloma, Sarah, Mirabelle in the Faculty of Engineering, Research and Knowledge Transfer Exchange team, and also to Susan Donaldson, who's the Fellowship Engagement and Events Manager for the Royal Academy of Engineering. So they provided invaluable help in organising this event, and we've been working on it, I think, since April, looking back through the knowledge. So it's my pleasure now to introduce our speaker for the evening, who's Baroness Brown of Cambridge, Julia King. Dame Julia is an engineer and a cross-member of the House of Lords. She graduated from Cambridge with a first degree in natural science, followed by a PhD in fracture mechanics. And then she was Rolls-Royce Research Fellow at Cambridge and then took up a post here at Nottingham. I think you were here for 7 years or so, we worked it out. She then returned to Cambridge and eventually back to Rolls-Royce. So in a very illustrious career includes 10 years as Vice-Chancellor of Aston University, and she was there before joining the House of Lords as a crossbench peer in 2016. And she is a Fellow of the Royal Academy of Engineering, which was gained in 1997, I believe. So Dame Julia's held many senior public appointments, and she worked closely with government on education and technology issues. So numerous climate change, which I'll just hand over for the lecture. So please welcome our speaker tonight. Our topical lecture given by Dame Julia is on delivering net zero, so much to do, so little time. So, thank you.
Thank you very much, Trevor. Well, thank you very much, and thank you very much all for turning out on this cold evening to listen to this. So let's hope I can get past the first challenge of making the technology work. Oh, yes. So I want to start just by reminding everybody why this is so important. So here's global temperature change since 1860. And you can see that since about the 1960s, it's been going irrevocably up. Okay. So that's that same data again, and that's data, that's global average temperatures measured. And the Paris Agreement, which of course COP is starting imminently, is countries agreed that they would aim to keep warming to well below 2 degrees with an ambition to keep global average temperatures to below 1.5 degrees. So as you can see, we're already getting pretty close to 1.5 degrees. And actually in September this year, we hit 1.75 degrees on average for the month. We're now being told that the predictions for this year are that already it will be at 1.4 degrees. Now, we haven't permanently reached 1.4 degrees. We've got an El Niño event, which, although it started quite late in the year, is starting faster than El Niños normally fast. So it is already affecting our temperatures. But I think it's pretty scary, really, that this year will be a 1.4 degree year, and it had a September that was already getting close to 2 degrees. So if we get to net zero by 2050, then temperatures will start to flatten off. And so the black dots represent a Met Office projection of what temperatures could look like to the end of the century if we reach net zero at 2050. But actually, it's not beyond 2050 I want you to think about. It's the fact that from now to 2050, or indeed maybe to 2060, depending on when we reach net zero, temperatures go on going up as fast as they have done over the past 10 years. We have had the hottest 10 years on record. Standing in 2050, people will look back, every decade between now and then will have been the hottest decade on record. And that's if we reach net zero in 2050. And if we don't reach net zero in 2050, average temperatures could look rather more like this. So it's pretty critical that we do. And we're already seeing the kind of impacts in terms of flooding, in terms of wildfires, in terms of drought, all over the world. And we're seeing plenty of them actually in Europe. This was in spring 2021 in Germany and Belgium, a weather system which could have been over the UK. Over 200 people were killed in those floods. And, you know, we haven't seen anything as bad as that. But last year we had temperatures hitting 40 degrees centigrade for the first time. But we're also seeing more storms. And we've just had Storm Babette, and the following storm, and Scotland suffered really badly, and indeed there was flooding in this part of the world as well. And as almost inevitably seems to happen, lots of people get affected by power outages because our electricity system isn't resilient to the weather we're experiencing today, let alone the weather we're going to experience between now and 2050. And we tend to think that it's the global south where climate change is happening fastest, but actually it's Europe, and particularly Northern Europe, where temperatures are now rising fastest, with temperatures in Northern Europe now rising at double the global average. And maximum temperatures in the southeast of England rising at about 1 degree per decade. Now, that's empirical data, that's measurements. That's not a prediction, that's what's happening now. So we certainly could be seeing 43 degrees centigrade temperatures by mid-century, and I wouldn't be surprised if we're seeing 45 if that doesn't accelerate further. And just as a reminder of the sort of extraordinary extremes we're now starting to see, the chart beside the map shows temperature variations through the year from 1940 to this year being the one in red. And you can see for all those years, there has never been an excursion anything like the scale that we saw in September this year globally. And that was the one that made climate scientists come out with all sorts of exclamations of, oh my God, what is happening here? That sort of excursion in temperature, that getting to 1.75 degrees as a global average for September. So we are seeing rapid changes in the climate, much more rapid than we've ever seen before. Much harder for us to adapt to those changes because of how quickly they're happening. And we're starting to see, as the last IPCC reporting said, we're starting to see more extreme extremes. So something that we need to be thinking about how we prepare for. We're also, of course, seeing the costs of this all mounting. This is some data from the insurance industry, so it's not an estimate of all the costs, but it's an estimate of the costs, some of the costs they're interested in. And we've seen that change from the decade 1980 to 1989 of them seeing 357 billion US dollars to 2010 to 2019, $1.4 trillion. So a rapid rise in the costs as perceived by the insurance industry, of course far less than the actual costs of the impacts of the changing climate. So just let's remind ourselves that this is happening and it is our fault. And we've known it was going to happen for a very long time. So back in 1820, FREng realized that in order to understand the temperature of the Earth's surface, he needed a coefficient in his equations. He didn't know what it was, but it was a coefficient that he had to put in to suggest that heat was being retained by the atmosphere. And then by 1860, Tyndall had discovered that it was the minority gases, in particular carbon dioxide, but also water and methane, that were actually absorbing the heat and forming this blanket around the Earth that caused us to warm up. And by the end of the 19th century, Arrhenius was thinking about the fact we were burning all this fossil fuel and did a calculation that suggested that doubling the CO2 in the atmosphere would give us a 5-degree temperature rise. Now, he didn't have any sophisticated modelling that said, and this is how much of the CO2 and the heat is absorbed by the ocean and all the things we're now able to do. But if you compare the atmospheric CO2 level in 1898 with the level today, he would have predicted we'd be seeing about a 2.1 degree temperature rise. In November, we're seeing about a 1.4 degree temperature rise. So the basic physics gets us pretty close to where we are today, given the lack of complexity of the calculation they were doing back in the 19th century. So there is no doubt about the science. There is no doubt that we are causing these problems and that we have to do something about them. And if we possibly can, we have to get to net zero by mid-century. So you'll see a lot of curves of how greenhouse gas emissions need to come down. And it can be quite confusing because sometimes they talk about CO2 and sometimes they talk about all greenhouse gases or CO2 equivalent. And if they talk about CO2, then typically they say we need to be actually down at net zero CO2 by 2050. If you talk about all greenhouse gases, then actually that in order to have a good chance of staying below 1.5 degrees of warming, the Paris Agreement level, we probably need to be there by about 2060, or even just a bit later than that. And that's why you sometimes hear China targeting 2060, and we shouldn't think because China is targeting 2060 that that's them not trying hard enough. We in the UK chose to target 2060 for all greenhouse gases because the Paris Agreement requires us to be consistent with the highest possible ambition, and that means it's the highest possible ambition for the kind of country you are in, and therefore it depends on how wealthy a country you are, how much your historic contribution to emissions are, and it should be fair and ambitious in the light of national circumstances. And obviously our national circumstances are very different from those of middle-income countries or developing countries. So our government committed us, on the advice of the Climate Change Committee, to reach net zero by 2050. We do that through a process that was introduced in the Climate Change Act, which is that every 5 years we have a carbon budget, the amount of CO2, or rather the amount of CO2 equivalent greenhouse gases that can be emitted in a 5-year period. And we've had carbon budgets now since the Climate Change Act was passed in 2008, and they now go out to almost to 2040, the 6th carbon budget. And the Committee on Climate Change are at the moment just preparing the 7th carbon budget, which will take us out, I think, to 2042. So we've met 3 of our carbon budgets so far. So the dark line shows the actual emissions trajectory, and the 3 dark blue spots show the levels of the carbon budgets. And you can see that actually we've been helped in meeting the carbon budgets by the fact that back in 2007 we had a global banking crisis followed by a recession, and back in 2019 we had a lot of help from the fact that we had a COVID pandemic. Had we not had those major international constraints on our economy and our behaviour, I think it very unlikely we would have met the previous carbon budgets. Anyway, we now have to worry about the carbon budgets going forward. So carbon budgets 4, 5 and 6. Carbon budget 5 is especially significant because it is actually our NDC, our nationally determined contribution, that has been submitted to the COP process. So that's the level of the red line on that chart. So that's the process we use, and each of our carbon budgets is legislated by the UK Parliament, and quite sort of in about 18 months' time they will be presented with a proposal for the level of the 7th carbon budget to be legislated. So I think you can sort of roughly guess what that's going to be if we're going to get to zero by 2050. So how are we doing? How have we achieved those emissions reductions? Well, for obvious reasons, I'm going back to 2019 because there aren't any trends for the last couple of years. So up to 2019, we had started to do really well on reducing emissions from electricity generation. That's the red line. And that's been, that sudden drop in emissions in electricity is as we've started to take coal-fired power stations off the system. Now, we've nearly finished doing that. So the line is not as steep as it was as we're gradually starting to replace things with, to replace gas with offshore wind and things like that. But that's now coming down rather more slowly. Industry has come down fairly consistently. A lot of that's been energy efficiency. Some of it's been a change in the nature of industry in the UK, but it hasn't predominantly been that. The blue line through the middle is now our biggest problem, if you like, now our largest contributor to emissions, which is surface transport. And the orange line below that is heat in buildings. Both of those are proving very difficult to reduce. And the other success story has been waste, which is the bright blue line towards the bottom, which landfill tax was the driver of that reduction. And as you can see, we need some new initiatives because that one has really bottomed out. And the line you can't see very easily, which gets hidden by the green line, but is the one that rises rapidly from 1995 onwards, that's aviation emissions. So we've got to get all of that to zero, or to net zero, by 2050. So the only thing that looks as if it might be on track pretty much is our electricity generation. So just as a kind of aside, so what did happen during the pandemic? Well, if we compare 2021 to 2020, obviously there was an enormous drop in aviation emissions and surface transport emissions during lockdowns. So in 2021, you were starting to see people driving again, but not yet flying again. And in 2022, you were starting to see people flying again, so a huge increase in aviation emissions. And you were also starting to see the impact of really high gas prices on the use of gas in buildings. So residential building emissions, even when you took into account the fact that it was quite a warm winter, residential building emissions dropped really quite significantly. So it'll be a while before we're kind of really back on track to understanding the trends in emissions, so we can assume they'll continue at the moment somewhere like they were doing before the pandemic, once we get back to a sort of balance again. But the one thing that we do seem to have noticed, and maybe a trend, or it's too soon to say, is that surface transport emissions have not quite got back to where they were before the pandemic, and that seems to be proving relatively consistent. And of course that may be associated with our change in working habits, and with so many people now spending more time, not all their time anymore, but more time working from home. So anyway, let's get back to the track we need to be on. The yellow dotted line going forward from today is the government's carbon budget delivery plan and their indicative pathway for reducing emissions. So that's a particularly important bit of policy. And what we need to do to achieve that is an enormous amount in the next 27 years. So this isn't all of it, but this is some of the biggest elements of it. We need an electricity system by 2050 that's twice the size it is today, maybe a bit more than twice the size it is today. We currently have about 15 gigawatts of offshore wind. By 2050, we probably will have around about 100 gigawatts of offshore wind. We'll need a grid that can cope with that, so a grid that has a lot more storage on it, a grid that actually enables us to move electricity from around the edges of the country and from the north down to the south, rather than from a ring of power stations around London into the metropolis. That's an awful lot more transmission and storage and flexibility infrastructure. We also need to make sure that works in the future climate, so it needs to be resilient. We're going to have to start a hydrogen industry. Hydrogen is not going to solve all our problems, but even to do the things we think it will need to do, it needs to be, by 2050, in terms of energy, 2/3 the size of the electricity system today, in terms of the energy it provides for us. We've got to start and scale carbon capture and storage. We've still got 29 million buildings that need low carbon heat, that are still heated with gas. We've got about 1 million electric vehicles. We need to replace the whole car fleet. They're going to need at least an order of magnitude more charging points than we have today. In order to get the net bit of net zero, we're going to need to be growing a lot more trees, amongst other things. So we're going to need to be reforesting and re-woodlanding the country. And at the moment we have this extraordinarily low woodland and forest cover of 14% of the UK. So that would need to go up by 4%. That sounds quite small, but that's an enormous change in land use, which will imply changes in agriculture, which will imply changes in diet. It thinks I should hurry up, obviously. So if you think about where do those actions, what kind of categories do the actions we need to take fall into? Well, in putting together the 6th carbon budget, the Climate Change Committee team categorised them in this way. The sort of purpley bits at the top are about reducing demand, using our resources and our energy more efficiently. So perhaps controversially flying a bit less, but certainly more of the circular economy. The orangey reddish bits are about essentially new technologies, taking up new solutions, mostly electrification, but a small contribution from hydrogen in some areas where electrification isn't effective. The blue area is this expansion of our electricity system, and the green area at the bottom is then the net bit, the negative emissions we're going to have, hopefully many of them from nature-based solutions, natural carbon storage, restoring our peatlands, forests and woodlands, but potentially also greenhouse gas removals and other potential carbon negative technologies. So it's an enormous amount to do. None of the individual lines on that previous slide are things we haven't done, things of that scale in a 25 to 30 year period, but it's an awful lot of them to do all together, probably a bigger challenge than we've had before. Underpinning that are some huge changes in fuel use. So there's this probably a bit more than a doubling in electricity demand, with particular growth in electricity being used to heat buildings. That's the 2 orange slices on there. Growth in electricity being used for transport. That's the blue piece at the bottom, which grows from almost nothing. And growth of electricity being used in industry. That's the pale grey blue, which is labelled M&C, which stands for manufacturing and construction. And then the turquoisey bit at the top is the use of electricity to produce other fuels, so to produce hydrogen, but also potentially to produce sustainable aviation fuel. A dramatic reduction in our use of natural gas, something like an 80% reduction, so that by the time we get to 2050, we're really only using natural gas potentially for electricity generation with carbon capture and storage, or for producing blue hydrogen, again with very high levels of carbon capture during the production. A 90% reduction in oil use, such that by 2050, just about the only thing we might still be needing to use that for is aviation, because the other solutions for aviation are so challenging and so expensive. And an increase in green and blue hydrogen production from essentially nothing to perhaps 200 terawatt hours. And apologies for the labelling on this slide. The 0 is really where 0 is, and 250 is really where 250 terawatt hours is. And the lines in between are all in slightly the wrong places. But it shows you the dangers of having somebody who isn't a scientist or an engineer make your slides for you. So apologies for that one. But hydrogen in 2050 being used in the grey part at the top, in probably one of the most significant uses for hydrogen being in industry, potentially some being used to generate electricity and some being used for shipping, but those being quite possibly the dominant uses for hydrogen. So it's absolutely not being used for everything, as some of the pictures of a hydrogen economy suggest. But I think it's very useful to reflect on the fact that lots of different models agree on some basic things. They agree that we become much more efficient in our energy use by 2050. So we use about 2,000 terawatt hours of energy today. And although we always talk about using lots of electricity, electricity is quite a small proportion of that. About 15% of that is used in the form of electricity. In 2050, we'll be much more efficient. Electric vehicles are much more efficient than internal combustion engines. Electric heating, heat pumps are much more efficient than gas boilers. We'll be much more efficient. We'll only use about half as much energy in total, but something like 70% of it will be in the form of electricity. So we become very, very dependent on electricity and indeed on the resilience of our electricity system. And just a bit more of an aside, in some ways, as we go forward, it's going to get harder to keep on reducing emissions than it has done. And one particular way that it gets harder is the fact that we and the general public all need to be much more closely involved than we have been to date. Because to date, most of the emissions reductions have come from manufacturing, energy efficiency in manufacturing, reducing the energy intensity of our electricity system, things that haven't affected the way we behave or the decisions we make every day or the choices we make. So something like over 80% of our emissions have not really had to have much in the way of reduction, have not really had to have much in the way of public engagement. As we go forward, the population as a whole needs to be much more engaged. There's something like 41% of future emissions don't really need us to engage with them, they'll just happen. But actually the other 60% need us to do different things, to make different choices, and to behave in different ways. So we actually do need to be engaging the public much more in this debate about how do we get to net zero and what are the roles they have to play. But the other more positive piece of news, I think, or less challenging piece of information, is that it's getting cheaper to do this. Now, it doesn't feel like that at a time when fuel prices are very high and the economy is very stressed. But when back in 2008, when the first 3 carbon budgets were set and the 2050 target of 80% reduction was set, then the estimate was that it was going to cost between 1% to 2% of GDP to get down to 80% reduction in emissions. The target is now 100% reduction in emissions, net zero, and the analysis for the 6th carbon budget indicated that actually the most likely cost was going to be about 0.5% of GDP. So it's cheaper now to get to net zero than we thought it was going to be back in 2008 to get to an 80% reduction, because we've seen such a phenomenal reduction in the costs of the key technologies. As the size of offshore wind turbines has grown, as batteries have got cheaper, as solar panels have got cheaper, it really has had the engineering developments have had a hugely dramatic effect on the estimated cost of reaching net zero. And I think, there's more of that to come. So I think as we go forward, technology developments are going to keep on driving this cost down. And other modelling suggests that actually the new industries that this creates will actually deliver GDP growth, which will more than cover the costs. The challenge is, of course, we've got to get from here to there, and at the moment, that's a big investment challenge for us. So a really strong message we have at the moment is that acceleration is needed. So if you look back 8 years from today, and you look forward 8 years from today, and you look at the rate of emissions reduction we're going to need, and this excludes aviation and shipping because, of course, the impact of COVID means that completely sends the figures haywire and means you can't really see any trends. But if you look at the total emissions allowed in 2014 and 2022 and 2030, according to the government's carbon budget delivery plan, then we have been reducing emissions at 2.9% per year to get to the 2030 carbon budget delivery plan figure, the government's own target, we've got to double our rate of emissions reduction. We've got to be at 5.6% a year. And if you take out the electricity system, which we know how to decarbonise and have been doing rather effectively, and we know how to continue to do that, then the picture looks even worse, because in the rest of the economy, we've been reducing emissions by not much more than 1% per annum, and actually we need to be reducing them by over 4% per annum. So moving forward just over the next 8 years to meet our next carbon budget and the government's own targets, we have got to quadruple the rate of emissions reduction. So there is real urgency here. And you can see the yellow bars show the change in emissions per year by sector going back 8 years, and the blue-grey bars are the forward 8 years. And you can see how brilliantly electricity's been doing, and it has to keep up a rate that's probably less than half that. But industry, surface transport, buildings have all got to massively accelerate the rate at which we're reducing emissions if we're to stand any chance of meeting our targets. So how are we doing? Well, the Climate Change Committee every year in June publishes its report on progress, and it published one on progress this year. And it uses, for every sector of the economy, what it calls a monitoring map approach. So here's the monitoring map for the power sector. And it starts with, well, what's the target in terms of our legislated carbon budget and in terms of the government's stated policies for delivering that? So that's the government's stated target is full decarbonisation of the electricity system by 2035. It breaks that down into what does that mean for emissions intensity, what does that mean for electricity demand, and then it breaks that down into a whole series of other indicators. So how rapidly are we building offshore wind, solar, nuclear, etc. How are we moving with electric vehicles, heat pumps, hydrogen production, etc., etc. And it goes through all of these outcomes, enablers, and then do we have the policies in place to deliver those? And then it gives the government our progress, essentially a ranking. And here is the one from the progress report in June this year. So surface transport, possible, not brilliant, but possible. Energy supply, doing better than just about anything else. Buildings, lots of areas where we really do need to be making better progress. Industry, some real challenges, and a lot of very significant challenges in agriculture and land. So this gives the government a very strong message about where the CCC assesses it needs to be trying harder and where we need more policy focus, and indeed in some cases where we need more data. And you'll see there are some areas like that, where, like car kilometres, which 3 years ago we would have been able to tell you was red, but because we don't quite understand yet the impact of COVID and whether car kilometres are going to build back up to the levels they were before, that's white, because we aren't yet able to assess what the current position is. So a lot to do still. And a lot to do, not entirely helped by some of the recent announcements we've had from the government. So the announcement on moving the phase out of petrol and diesel cars by 5 years. The announcements in the Prime Minister's September speech about delaying some of the measures that should have been driving the change to more electric heating in homes. And of course the fact that there were the strike price for the offshore wind auctions, recent offshore wind auctions, were so low that none of the developers bid into the most recent round of offshore wind auctions. On the other hand, there have been some positives. There's been the funding for Tata Steel, to support Tata Steel for decarbonising their plants in Wales. And the boiler upgrade scheme has been increased from £5,000 to £7,500 grant, which will enable some more people to put in heat pumps. And we've just had the response to the Nick Windsor review talking about fast-tracking grid infrastructure, and the government has recently just accepted all of Nick Windsor's proposals for accelerating progress with the electricity transmission system. So a mixed picture. I think actually the main problem of the noises that have been interpreted as coming from government is the impact they've had on investors, and particularly international investors, because this transformation of our economy and our energy system needs about 50 billion of additional investment a year, and that's not going to come from the UK government and UK taxpayers. That's going to come from international investors. And if they think we're not serious about our carbon targets, they've got plenty of other places who at the moment look as if they may be being a bit more serious about theirs. And we have indeed seen a quite significant drop in international investment in the UK in recent times. So I think there's a real concern that the government is giving some mixed messages which are not actually helping with progress. So that's where we are on net zero, and I think, you know, a real need now for focus and acceleration and engaging the broader public. But I'll come back to what I was saying at the beginning, and the clue is in the fact that I chair the adaptation committee of the Climate Change Committee, that the temperature goes on going up until we reach net zero. So climate impacts are a function of the hazard that's being driven by the temperature increase, but they're also a function of how exposed we are to those hazards and how vulnerable we are to those hazards. And of course, if you're in a low-lying island state, you are particularly exposed and vulnerable to those hazards. But in order to reduce climate impacts, we both need to make sure we're doing everything we can to reduce our emissions, but we still need to be thinking about how are we addressing exposure and vulnerability, because the impacts go on getting worse for quite some time. So baked into the system already is that in the UK, we're going to see at least another 0.6 degrees of warming by mid-century. So it'll be up to 1.8 to 2 degrees if we get to net zero. That something we would call a heat wave summer this year, like the 2018 summer and indeed last summer, that won't be a 10 to 25% chance. That'll be an absolutely typical summer. Summers will be very hot. Summers will be very dry. They will be, the mean of the projections suggest they'll be 11% drier, but they could be 24% drier. And in East Anglia, where we grow an awful lot of crops and have a lot of lowland peat, they are likely to be nearer the 24% drier, I suspect. It'll actually be wetter overall, so there will be drought and wildfires, but also more flooding. Average winter rainfall will increase. It could be as much as 16%. More of that rainfall will fall as very short periods of extremely heavy rain, causing things like surface water flooding, in, particularly in paved city centres, and sea level goes on rising. So we've got to be prepared for that, whilst also be reducing our emissions and building the new infrastructure that we're going to need for that. So we just need to make sure that we think about where we build the infrastructure and whether it's going to be resilient. Thank you very much.
Fantastic lecture. Dame Julia has a tight schedule, but is willing to take questions. Because of recording, maybe you can use the microphone if you do have a question. So, perhaps you just say who you are and the question. Thank you.
Yeah, Shahrukh Shahpal from Rolls-Royce. Thank you very much for your very interesting lecture. I understood the risks and mitigation about CO2, but I would like to know your opinion about direct air capture and the fact that, not to ignore the, all the sources you mentioned, but as we know, there are a number of solutions out there that we could capture the CO2 and bury it somewhere.
I think it's a technology we should be looking at. I mean, clearly it looks to be, at the moment, hugely expensive and very energy intensive. So that's not, at the moment, that doesn't look like a great prospect.
So maybe a SMR plus stack?
But on the other hand, we need to look at all of these potential solutions. We need to be thinking about, what are the options for driving cost out of them in the way that we've been able to do with some of these other solutions. And although it may not be a solution, by 2035, we're going to need solutions for 2050, we're going to need more solutions for 2060. So I think it's something we should look at. In the nearer term, I think there are some other really interesting carbon capture technologies that might work on combined cycle gas turbines. There are some interesting sort of metal oxide framework technologies that will absorb CO2, and I was talking to a young company only on Monday who have developed a material that doesn't need to be heated to high temperatures to release the CO2. The CO2 can effectively be pulled out by vacuuming it, so at much, much lower energies. So it's great to see these innovations coming along. We need more of them. We mustn't assume, however, we can do nothing and there'll be a brilliant hockey stick when we get to 2045. We've got to be supporting these brilliant new innovations whilst also getting on with doing the stuff we already know how to do, because we have most of the technologies to be getting on to be on the path to 2050 already. And all of the new innovations are going to be a bonus, and I'm sure will help us get there quicker and get there cheaper as we develop them.
Thank you. Since I've got the microphone, can I ask a second question, or
Yes,
related to
please
my,
do, and then
my,
there's a
my
question at the back, I
discipline
think.
with
So,
Rolls-Royce?
Please ask the second question.
I noticed on your chart for aviation we were quite small. Do you think the hydrogen would be, should we take hydrogen seriously for aviation or not?
I've been really impressed by the developments we've seen in hydrogen for aviation. If you'd asked me, I don't know, 7 or 8 years ago, I'd have probably said, "Ooh, doesn't sound very likely." But I mean, we shouldn't, in a way, we shouldn't close our minds to what innovation can deliver and what really committed engineers can do. So it does look like there may be some applications where hydrogen is of interest. And of course, when you compare the price of hydrogen with the price of sustainable synthetic aviation fuel, hydrogen really does look quite a cheap alternative. So you can see why, as an engine company, you'd want to make sure you were driving solutions that could use hydrogen.
So one at the back and then two down. Yeah.
Hello. Hi. Thank you very much for your talk. It was really interesting. I don't know why I'm standing, but hi. Yeah. So you mentioned that, to achieve our goal, there is the need of investment, reduction, etc. But I also think that there is a need of changing in behavior and in education. And I think university is the best place for that, isn't it? So I was thinking, if you can share with us, in your opinion, what university should do, because I strongly believe that we should provide a great example for society and said, we are trying to solve, or we are trying to give you an example on what we said. So what do you think? What we can do?
I think that's a brilliant question, because as you say, I think universities have a hugely important role to play, and it's not just about educating the engineers and scientists and doing the research. It's actually about making sure that every student who comes in through the door of a university understands the world that they are going to be operating in, and how this is going to affect investment, how this is going to affect banking, what the medical implications of the changing climate are going to be, and also about what every one of our personal responsibility to do something to help make this change happen is. So yes, it's absolutely about making sure every person who comes through the door of the university is educated to understand the implications of climate change and what we can do about it. Not just, this particular engineering course or that particular sustainable technologies course.
Yeah. So there's a cluster of questions at the back now and then in the middle.
The UK population is less than 1% of the world population, and the other 99% or so, many of those countries are very rapidly developing. Do you think doing this in the UK is going to have any influence at all on climate change? It would be nice to believe that if we take the lead, others will follow, but I must admit I'm very sceptical. It seems to be we're in for a big problem.
Well, we have been hugely influential. We have, I think, now about 70 countries who now have climate change legislation and climate change committees and processes that look very similar to ours. We have been educating other countries in how to approach looking at emissions reduction. In my view, we should be doing more in terms of our international development work in supporting decarbonisation of developing economies and helping them to move to the next generations of technologies rather than getting stuck with building coal plants. So we have been hugely influential. I have a fear that if we're not careful, we could find ourselves being rather less influential if people think we are not walking the talk on this one and not doing what our own legislation says we should be doing. And, either we can try and be influential and try and support the rest of the world to do the right things, or we can give up. And I'm not one for giving up.
So two questions over there, one in the middle. Susan.
Leaning on very closely from that question, of course, for the vast majority of most of what we do in this country, we do rely on foreign imports, power, and all of this sort of thing. To what degree does that show in these graphs? So, for example, the degree to which manufacturing occurs abroad. Like, are we including that or not including that in our climate agenda?
You make a very good point. All of the accounting for the country's commitments to the Paris Agreement are on the emissions we generate here. So these are just our production emissions. They don't include our consumption emissions. So countries like China are, if you like, taking the hit for an awful lot of emissions for goods that we consume, goods that are consumed in the United States and in the rest of the world. So these are production emissions only. We do in the UK attempt to record and monitor our consumption emissions, so our carbon footprint as a country. That's data that is collected by the government every year. Of course, it means that they have to estimate the average emissions levels for production in other countries, so it's not necessarily such high quality data as the data that refers to us. And our consumption emissions are about a third more than our production emissions, and they have started to come down as other countries are decarbonising, but they're not coming down anything like as fast as our production emissions have been coming down.
So one more question over there, two in the middle.
Hi, my name is Chris Sims from the University's Institute for Policy and Engagement. I was just wondering if you could comment on the extent to which you think government policies are currently geared towards ensuring that the transition to net zero is a just transition, but also whether we have the mechanisms to hold government to account equally on that question as on the question to the transition to net zero itself.
I think people in government are very aware of the need for this to be a just transition. I don't think we have the right policies in place to do that. I don't think there's been anything like enough thinking yet on the skills and the changes in skills and the retraining opportunities for people. And I think that's making people in some industries feel quite anxious. And we see that in some of the statements that are coming out from some of the trade unions. And I think we need to be being much more proactive in making sure people understand that, you know, there will be opportunities for retraining. They won't come after they've been made redundant. They'll come whilst they still have jobs to ready them for the next jobs and things like that. And I don't think we've done anything like enough thinking or planning on that at the moment. And indeed, I think, you know, the skills agenda in this country is one that industry generally is very worried about. And in particular for green skills, it's a particular concern. But I think at the moment that the challenge is that a lot of people think their jobs are going to disappear and they don't yet see where the training or the new jobs are coming from. And government needs to be being, I think, much more proactive in getting that message out and actually putting that support in place. So I think, you know, people have recognised that it's going to be important. I don't think we're doing enough to address it yet.